Hey, it's Mr. Peterson. This screencast is about enzymes. Number one, enzymes are proteins. Enzymes control chemical reactions. So if we think about, there's a marshmallow, thinking about warm summer days and making some marshmallows. You can eat that marshmallow. You can get some energy from it, right? So the marshmallow is composed of molecules like C6H12O6. And typically what you would do, right, is you would burn that. You would start it on fire. Ooh, nothing better than a black marshmallow. And what's given off is carbon dioxide and water. Now, that's the same reaction that you and I do, but we don't have any open flames going on in our bodies because of enzymes. So enzymes are proteins that control chemical reactions, that keep them moving in one direction or the other. They build things up or they break things down. Enzymes are proteins. So chemical reactions either release or absorb energy. So think about that chemical reaction of the marshmallow. It's releasing energy. Well, the marshmallow just didn't burst into flame by itself, right? No, you have to add a little bit of energy to it, right? So you have to hold it over the fire. You have to add some activation energy. And once you add the activation energy, what happens? Well, energy gets released and the reaction becomes spontaneous once you add some activation energy. So what enzymes do is they lower the amount of activation energy needed for a chemical reaction to happen. So we're going to break down the carbohydrates in a marshmallow, but we don't have to get it nearly hot enough to get it to burn inside of our body. So we're burning those marshmallows and we're going to release some energy. Okay? So enzymes lower activation energy of reaction. So if we think of like the chemicals in our body or the things that you eat, when you take them in, they're at a relatively stable state. But enzymes have the ability to bring things close together and in some special chemical reactions that happen in the enzymes, and we make them less stable. And once they're less stable, then reactions will tend to go. So in this silly little model here, we get the ball out of that comfy spot to a less stable state, and then it rolls down the hill. And so if we look at this diagram of free energy, and free energy is the kind of energy that we need to do cellular work. So going up the y-axis, that's increasing free energy, and then going from left to right, that's the course of reaction. So you can see the hill with or without the enzyme is quite different. And so the ability to use less energy to get a reaction starting is one of the key components of enzymes. So enzymes control reactions. Sometimes they're called catalysts. You've probably heard of catalytic converters. So catalysts are also found in cars. They're not biological enzymes, but they're catalysts. They help reactions happen. And so enzymes are needed for almost all the process in cells. They control rates. They keep things going forward, and they keep them from happening too quickly. So here's a girl with flashcards.
Won't that be fun?
Ooh, check.
Triangle.
Check.
Good. House. Good. Campfire. Don't panic. Leave me on fire. Leave me on fire. My baby! Nice baby.
You know, Jack probably has something wrong with his enzymes. He released the energy too quickly. And the poor babysitter, I think her name is Carly. Carly the babysitter. Have you ever seen a exploding baby, Mr. Dicker? You remember that scene from The Incredibles? so enzymes help control reactions and keep us from bursting into flames. So here's an enzyme called amylase that has a specific function and a shape And the function is tied to the structure. So if we look at this animation, so amylase is a globular protein, and it has some important things called active sites. And notice the shape of those. So here's the enzyme. Here comes a substrate. And the substrate happens to be a starch molecule. And what's going to happen? Well, some chemistry is going to happen, and this enzyme is going to break this starch molecule into smaller pieces. So the enzyme acts on the substrate, and it acts on the substrate over and over and over again. Right? So the enzyme is reusable. That's the function of that enzyme. Enzyme shape is really important. So the enzymes have an active site, and at the active site is where the substrate binds, and that's where the chemistry happens. And so enzymes and substrates have complementary shapes. That lock and key model, where the substrate fits into the enzyme, there's some bonding that helps the substrate become unstable. And depending on what type of enzyme it is, it's either going to build things up, put things together, or it's going to break things down. So here's a classic animation. This animation is amazing. So here we've got an enzyme. Yeah, I know you're thinking, that's just a sponge, Mr. Peterson. Right? So that enzyme took compounds A and B and made compound AB. But different enzymes can work the other way, right? So sometimes they'll take compound AB and they'll make molecules A and B. So they can work both directions. Now, different enzymes will perform this function. So in this model, that kind of falls apart. All right? So classic animation. All right, some things to pay attention to. Enzymes are proteins. They're catalysts that control rates of reaction. They lower the amount of energy that it takes for a reaction to start. They have a specific shape and an active site. Only specific molecules called substrates fit, and the enzymes, depending on what kind they are, can break things apart or put things together. Enzymes. I hope that helps.